Welcome. In this video, we're going to talk about the ideas of how to approach problem 64. In this case, we're given a particle which moves horizontally in a uniform circular motion over a horizontal xy plane. At one instant, this particle moves through a point at coordinates 4 meters along the x and 4 meters along the y. And the particle, when it passes this point, its velocity is minus 5 meters per second I hat, and its acceleration is 12.5 j hat meters per second squared. And here we're asked to find the x and y coordinate of the center of the circular path. So one of the key things, or maybe one of the key ingredients in this problem, is to realize that the center of the circle being traced out by the particle undergoing uniform circular motion need not be always in the center of a coordinate system. It need not be at the origin. It's possible that our origin is elsewhere. It's not actually at the center of the circle being traced out. For instance, we could have a coordinate system that lives somewhere here, for instance, just for argument's sake. This point would be 0, 0, but that one would not be 0, 0. It would be some amount of, we would read off different x and y coordinates. And this is the situation in this problem. And we got to use uniform circular motion to figure out what are the coordinates of this center. So what we do know, though, is when the particle passes a region whose coordinate is 4 units along the x and 4 units along the y, its velocity is given by this thing here, minus 5 I hat meters per second. And its acceleration is 12.5 j hat. So, excuse me. What we do know about the acceleration in uniform circular motion is that it always points toward the center of the circle being traced out by the particle. Here's the center of our particle, and here's our acceleration vector. The question is, if this is our acceleration vector, which has a positive y component, where is the particle located on the circle in order to have an acceleration vector that looks like this and also points toward the center? Let's draw what this line would look like for the acceleration vector. This line would look something like this. This would be our acceleration vector. If this were a coordinate system, let's suppose our coordinate system was y this way and x that way. Our coordinate system here, our acceleration vector would look something like this. I'm going to draw them side by side in order to make them clear. But the point is, our acceleration vector points upward. So the question is, where must we be along this path so that a line which has this orientation points toward the center of the circle? Well, this means we have to be somewhere down here. This is where we have to be for this to be true. So we're going to do exactly that. Let me change colors and draw it this way. This is our acceleration vector. And we're told that when the particle passes, when it has this acceleration vector, its coordinate here is actually 4, 4. That is 4 units along the x and 4 units along the y. So this means if we were to go 4 units down, we would get the 0, the x-axis, and if we were to go 4 units across, we would get to the origin of this coordinate system. So this means our coordinate system is something like this, for argument's sake. Something like this. So that this point here is 4, and that point there is 4. So this is y, and that is x. So now, The question is, what is the x-coordinate of the center of the circular path? Here's our circular path. What is its x-coordinate? What is the x-coordinate of anything on this line? Well, the x-coordinate is going to be 4. So for part A, we can figure out that the x-coordinate here is going to be 4 units. So part A, let's say part A, the x-coordinate is going to be 4.00 meters. Now, what about the y? This is part B. What is the y component or the y coordinate of our origin? Sorry, not origin, of the center, this point. We figured out the x. Could we figure out the y? Notice the y component is higher than this 4. By how much is it higher? What is this distance here? This distance is a radius of our circle. So if we could find how long the radius is, and we were to add that the amount of the radius here, the distance, the length of the radius here, we would get to the center of our, to the coordinate of our center. So my point is, what I'm trying to say is this, that the coordinate here is actually going to be 4 plus the length of the radius. So how do we find the radius here? Well, we're given the acceleration vector and we're given the velocity vector. So if we were to find the magnitude of these vectors, we can use them to find the acceleration. I'm sorry, the radius. So from this equation, v squared over r, we know that we can find r, which is going to be v squared divided by a. And I should emphasize that these are magnitudes. Maybe I should do it this way. These are magnitudes. So I believe you should be comfortable with finding the magnitude of v and the magnitude of a and calculating the radius. And once you calculated the radius, you add it to the 4, then you will find the y component of this, the center of the circle being traced out. Okay, I'll conclude this video here and see you in the next one.